My name is Gary Hansen. I'm a consultant for American Safety and Health Management Consultants, and we're going to talk about two subjects today. First one's going to be hazard communication. The other is going to be personal protective equipment. Hazard communication is OSHA's single most cited standard of all times. Been out since 1983. It came out as a result of a study done by NIOSH. NIOSH is the National Institute for Occupational Safety and Health. They are headquartered in Cincinnati, Ohio, and they have a research facility in Morgantown. And they studied the impact of occupational disease on the American workforce for a 10-year period. And they came up with the conclusion that over 300,000 American employees were coming down with some kind of occupational disease. Many of these are recognizable today. If you go out, you can see asbestosis, lead poisoning. Where I grew up in eastern Ohio, pneumoconiosis, black lung disease, that beryllium poisoning, cadmium poisoning, all kind of other exposures. Wood dust is one. It's a carcinogen. Sand, silica. Crushed silica causes silicosis. So a lot of Americans were coming down with various diseases, and there really wasn't a federal standard to oversee workplace safety. So in 1983, as a result of the NIOSH study, OSHA came up with what they call the Hazard Communication Standard, also known as the Employee Right to Know Standard. Now, this standard, since it's been in place, is very cumbersome for most employees to comply with. It requires us to have an individual titled the Hazard Communication Coordinator who has to oversee this program here. It requires us to make sure that we have training for all brand new employees at the time they start. We have to cover all the types of hazardous chemicals that we have employees exposed to, what employees can do to protect themselves, the types of personal protective equipment that we have available to use. We have to make sure they can read a material safety data sheet, which has now become a safety data sheet. They have to know where the material safety data sheets are at. We have a master chemical inventory list. We have to have labeling for all of our chemicals. Anything that comes in from the outside has to have a label. Anything we take out of a label container and use internally has to have a label on it, and we have to follow up on this at all times. If we have a chemical that we take out of service, we no longer use it, we have to date stamp that, take that out of service, and keep it in an out of service binder for 30 years. All brand new chemicals coming in have to be date stamped. We have to insert that into our material safety data sheet binder, update our master chemical inventory list, and anybody that's exposed to that particular chemical has to be trained in the types of hazards of that chemical, and again, what they can do to protect themselves and the required personal protective equipment. As I mentioned before, the standard has been a real pain for companies to comply with because it is a paperwork nightmare in many cases. You got training documentation, you got the labeling program, you got the material safety data sheets, you got the constant follow-up. But on the other side, for us employees, it's been a great standard because it has really required a lot of major corporations to take many of the really bad chemicals out of service. For example, asbestos has not been allowed commercially in the United States since 1978. Lead is completely out of all products here. As a matter of fact, we don't even make any lead in the United States anymore. No lead in the toys, no lead in the paints, no lead in our gasoline. So lead has pretty much been taken out of service. OSHA's also implemented many new standards on various kinds of hazards that get into the environment. For example, the silica standard has recently been cut in half. The beryllium standard has been cut by almost 98%. So OSHA is working constantly to lower the PEL, or the exposure limits for employees. Employers have to put engineering controls in place, administrative controls in place, training in place. So today, we are much better off because many of the really bad chemicals that were in production in the 1960s have been taken out of production. We have a lot better training today, a lot better ventilation. So the standard has done what OSHA has asked it to do. But again, it's up to us as a company to make sure we're doing all the things to comply with the standard. Standard came out in 1983, again known as the Hazard Communication Standard or the Employee Right to Know Standard. And it's been very, very effective. There's been very little changes over the years since this standard's been in place. The standard says we have to have a written program. Each of our facilities has that program. We should have a safety manual for every facility. In that safety manual, there's a section for hazard communication. outlines all the things we're going to do as a company to comply with the standard. It starts out with the purpose of the standard. OSHA always puts in there, every one of their standards, what is the purpose? The purpose of the standard is very simple. It is to protect our employees, our most valuable assets, from exposures to chemical hazards for which they may not be aware, or protect them from hazards that they are using chemicals, especially chemicals that can have long-term hazards that can be organ toxic over a long period of time where the employees may not be aware of that. We have to have our own policy. Our policy at Palmer Donovan is very simple. We're going to do everything we can to comply with all aspects of the Occupational Safety and Health Administration Hazard Communication Standard. We're going to make sure we have all the training required. We're going to have the written manual required. We're going to have training for all of our employees, new employees and existing employees. We're going to have a labeling program in place. We're going to have material safety data sheets. We're going to have the master chemical inventory list. These will be immediately available to all employees in all of our locations, and we're going to have follow-up readily available. And if any of our employees have questions for any reason, we're going to make sure that we have people immediately available to assist them, answering their questions and helping them read material safety data sheets. Now, recently, OSHA has added to their hazard communication program what they call the globally harmonized system. This came about because too many companies were sending their products all over the world, but they were manufacturing these products in third world countries like Malaysia, India, Pakistan, Thailand, China. And these chemicals are being shipped all over the world, and there is no national or international regulation for what is to be on the labels for those chemicals. So a lot of chemicals are coming here inadequately labeled, mislabeled, extremely hazardous, and there's been no international body to oversee that. So there's a big concern about that. So what happened is 10 to 11 years ago, the United Nations, the United States, and the European Common Market have got together to come up with an international standard for labeling and identification of what is in these hazardous containers. So they call this the globally harmonized system. It impacted us because OSHA changed their standards in 2013. EPA is changing their standards. Federal Aviation Administration, DOT, Railroad Administration, all been affected by this here, and everybody in the federal government and all the agencies have had to update their programs. What it's going to require starting in 2013 is training for all of our employees on the globally harmonized system and the changes that have taken place in that. Starting in 2015, it requires all manufacturers after June 1st to no longer send products out that have the original labels on them. They now have to have the new GHS label on there. Also, they have to update their material safety data sheets. So material safety data sheets have to be sent out. Now, also as of December 1st of 2015, all warehousing operations, something like ours, if we're sending products out, we can't send products out anymore unless it has the new label on it. So we got to make sure that we are not sending anything out with the old labels on it. And then as of June 1st, 2016, all manufacturing and other businesses in the United States have to be in complete compliance with all the changes in the GHS program. And that means, again, updating their written programs, making sure they have new employee training, existing training, making sure we're changing our labeling to match what the new standard requires, and updating our safety data sheets and making sure that all new safety data sheets coming in meet the new requirements. Now, again, you got a slide up here that shows you what OSHA requires basically in the hazard communication program. Again, we have to have the written program, which we have. It is in the safety manuals in all of our facilities. Every one of you have a right to read that if you wish. Labeling, we have to have labeling coming in from the outside that meets the new GHS standard. Plus, internally, if we take it out of a label container, we have to make sure it is in a internal label container. Training of new employees, all brand new employees have to be trained at the time of hire, and then we have to have ongoing training. That means reinforcement training, because OSHA has determined that employees forget very quickly what they have been taught if we don't follow up on it. So they want to make sure there's what they call competency. Competency means if OSHA comes out and asks somebody if they know anything about our hazard communication program, know anything about our labeling, know what a hazardous chemical is, they can answer that question reasonably intelligently. We have to have the master chemical inventory list that has to be constantly updated. And again, we have to have safety data sheets. It used to be called material safety data sheets, but these have been updated, and they took the material for some reason off of the labeling. The globally harmonized system is an international approach to hazard communication. Again, it came about with the United States, European Common Market, and the United Nations. United Nations actually has a guide booklet. It's called the Big Purple Book. I have that book. I have read it. It's 600 pages, and it deals with how every company and industry is going to have to classify hazardous chemicals in the future. It is a very scientific approach to make sure everybody is using exactly the same classification methods. And you can go into that Big Purple Book and you can read it. And so every company out there that's shipping products internationally into companies or countries that have the agreement are going to have to do this. So nice thing about this is China and all the other third world countries, if they want to ship products in the United States or into Europe or Canada or any of the civilized world, they're going to have to follow the same method to classify their hazardous chemicals. It requires an update of the labels so that we have brand new labels that have a lot more information at the point of contact. So those labels are going to help a lot more. When you look at a label, there's a lot more information on there for us. And again, they're updating the safety data sheets with a lot of new and updated information. So overall, this is going to be a good approach. It's going to help us as employees. Again, it's a little bit of a burden on manufacturers who have to update their SDSs and have to update their labeling. But for us as employees, it's going to be a real help. Now, most of the program elements under the Hazard Communication Program have not changed. All the things I mentioned earlier are pretty much going to be in the program. What you're going to have, again, is you're going to have a new system to classify hazardous chemicals, and that's basically going to be for the manufacturers of the chemicals. That's going to be for the importers and distributors. That's going to be their responsibility. If we're not manufacturing chemicals or altering chemicals, then that won't be our responsibility. We're going to have to know what kind of physical hazards we have and health hazards. This standard covers health hazards and physical hazards. Also, they have added some environmental hazards. So if there's anything out there that's what's called ecotoxic, kills the fish, the birds, the worms, those are now going to be covered by this standard, but that will be a requirement of the EPA, Environmental Protection Agency. That's not going to be an OSHA regulation, so you have some crossover there. Again, we're going to have new labels, and we're going to have updated safety data sheets. And again, everybody needs to be trained in the new programs, and we have to have this follow-up training done so everybody, again, has competency. Again, here's some of the dates that I talked about earlier. June 1st, 2015, all manufacturers, importers, distributors have to be in compliance. They can no longer send out products with the old labels on it, and they also have to update their material safety data sheets. December 1st, 2015, all distributors that ship products out can no longer ship out product with the old labels on them. They have to make sure that they come into compliance, which, again, was well over a year ago. And as of June 1st, 2016, everybody else has to be in total compliance. We have to make sure that we have in place the new labeling program in place. We have to have the updated written hazard communication program. We have to have all the training necessary. We have to have a program in place to get the brand new safety data sheets, and we have to update our old sheets where necessary. These are basically the types of health hazards chemicals that OSHA is concerned with. Again, this standard covers health hazards and physical hazard chemicals, and EPA covers ecotoxic chemicals. So it doesn't cover everything out there. There are chemicals that we may get in that OSHA may not consider hazardous, but the vast majority of chemicals that we use on site are going to be considered hazardous. Rule of thumb to remember when dealing with a hazardous chemical: can you eat it? Can you drink it? Can you breathe it? Can you get it on your skin? And will you give it to your kids? If there's no to any of those answers, that's going to be a hazardous chemical. Windex can be a hazardous chemical because it has ammonia in it. If you drink Windex, it's going to make you extremely sick. So many chemicals out there that we don't think of as necessarily as highly hazardous can be considered hazardous. But this is a list right here, basically right off the bat. Acute toxicity. Acute toxicity means this product will kill you in 4 hours. So that's what that means. So if you get it on your skin, If you breathe it, if you drink it, anything like that, that product there is deadly. Skin corrosion, irritation, serious eye damage, eye irritation, respiratory or skin sensations, germ cell mutagens. Mutagen is anything that changes the gene structure. Also, if it changes the gene structure, that can be passed on to the next generation. So it's a very serious concern. Carcinogenity, anything that causes cancer in any way. Again, asbestos, lead, silicosis, exposure to crushed sand, those are all cause carcinogenic effects on the human body. Reproductive toxicity, target organ systemic toxicity, single dose. This means you breathe it one time, you get on your skin one time, and you're done. Here's the other one, target organ systemic toxicity, repeated exposure. This one here is a very insidious type of chemical exposure, because many times when people don't realize they're being exposed to something that's going to ultimately end up in permanent disability or even death. For example, get exposure to asbestos over a long period of time, exposure to lead over a long period of time, exposure to crushed sand over a long period of time, even wood dust. If you got employees exposed to wood dust, that's why we have to have ventilation on our saws, housekeeping on it, because wood dust is a carcinogen. You breathe that in over a period of time, it can have repercussions of throat cancer and lung problem. Aspiration toxicity, this is pretty serious. You drown in your own bodily fluids. Does that sound pretty disgusting? Yes. These here are what they call physical health hazards. These are pretty common. These have not changed. Anything that explodes, anything that's a flammable gas, anything that's an aerosol, those little aerosol cans that we have, that we spray, they have a propellant in there, which is usually butane or propane. So if you heat those cans up, they will explode. If you spray them out, you can light them up. You can put a match to them. They've got a little mini torch to them. So aerosol cans. Organic peroxide. Organic peroxide is a product, it's a curing agent used in the rubber industry quite a bit. It creates a tremendous amount of heat. Organic peroxide, when it's in a vapor form in the presence of air, can ignite. So it can be very, very dangerous, but it is an oxidizing type product. It accelerates the process of combustion, and it creates a tremendous amount of heat. Gases under pressure. If we have any compressed gas cylinders such as propane, propane is a compressed gas cylinder. If we have any welding, cutting, burning going on at any of our locations, oxygen cylinders, acetylene cylinders, nitrogen, these all fall into this category. Anything that's a flammable liquid. Gasoline is a flammable liquid if we're using that at any of our locations. Flammable solids, self-reactive substances, things that just sit on the same table react violently. Pyrophoric, anything that burns by itself. Again, it just sits on the table. It will automatically ignite by itself. Any solids, liquid, self-heating substances. Anything that emits flammable gas in contact with water. This used to be referred to as water reactive. So if you put it into water, it's going to react violently. Oxidizing liquids, gases, and solids. Again, oxygen itself does not burn, but oxygen accelerates the process of combustion. And if you have a torch at one of our facilities there, and you mix the acetylene and the oxygen, it will create a temperature at the torch of 6,000 degrees. So oxygen is an accelerator. It accelerates the process of combustion. And anything corrosive to metals at all or anything else, anything that's highly corrosive, any acids, any strong bases, anything like that there, that is corrosive to metal. Also, you have, in some of these cases here, you have some flammable metals, such as magnesium, which also react violently with water and also are highly flammable. But anything that we have that would be considered a health hazard, anything that we have that would be considered a physical hazard, has to be included in our program, and it doesn't have to be that serious. Again, if you can't breathe it, if you can't drink it, if you can't eat it, if you can't get it on your skin, and you will not give it to your kids, it has to be considered a hazardous chemical, and we have to be aware of that, and we have to make sure our employees are aware of that. Again, labeling. What is the purpose of the labeling? Obviously, to provide immediate warnings to our employees of the hazards of the chemical. In the past, OSHA only required 4 things on a label that came in from the outside: the name of the manufacturer, address of the manufacturer, hazard warning, and the name of the chemical. So those 4 things had to be on there, and many times there wasn't a lot of information on the labels. If you look at a lot of these labels, there were very little information about the hazard of the particular chemical. Now they have changed that. There's going to be a lot more information about the hazard of that chemical on there. So that's what they're changing right now. Identify hazards and safe use. So all new labels on there are going to have a series of new sections that will provide us as a lot more information. The new ones are going to be called the GHS labels. These have to be on all products coming in from the outside. If we take a product out of a GHS label, we can still use alternative labels. We're allowed to use alternative labels. 2 of the most prominent are the Hazard Material Identification System and the National Fire Prevention Association, NFPA. Those are very common. In the past, those were allowed to be used by manufacturers, but in the future, they're only going to be able to use the GHS label, although they are able to use these as supplements to that label right now. National Fire Protection Association, again, has been one of the standard labels out there. It's been around for a long time. It's been an approved label, and also the HMIS, Hazard Material Identification System. Both types must identify the chemical name and hazard. Manufacturers can no longer use that as their primary label, but we can still use those or other alternative labels internally. Up on the screen is a copy of an NFPA label. This is a standard label. Many of you probably have seen this label in the past. It is the diamond label. It's got 4 different colors in there. The bottom one is white, although it shows up a bluish on the screen. Here's actually white. You got dark blue there for health hazards, red for flammability, yellow for reactivity, and the white is for special or specific types of hazards. That means this product is very, very dangerous. If you see anything in the white on an NFPA label, this product is extremely dangerous, and I discourage these types of products being taken out of the regular standard labeling container and put into an internal container because it's way too dangerous at that point. Health hazards, flammability, and reactivity. Now you also see we have a little numeric code identifying the degree of hazard for each class. There's 0 under health hazards, normal material, 1 is slightly hazardous, 2 hazardous, 3 extremely hazardous, and 4 deadly. So if you see that label and you see a 4 in it, you know it is a very seriously dangerous chemical. Same thing with flammability. 0, it will not burn. 1, slightly hazardous, means if you heat it up over 200 degrees, it will catch fire. 2 means it is combustible. Combustible means it has a flash point below 200 degrees and above 100 degrees. It is combustible. Kerosene is combustible. Diesel fuel is combustible. They have a flash point well above 100 degrees. Extremely hazardous means it has a flash point between 100 degrees and 73 degrees. It's highly flammable. And then 4 has a flash point below 73 degrees. Propane, gasoline, things like that fall into these categories here. So we have to make sure that we have adequate labels internally, look at the safety data sheet, see what it says when we use this here. And then under the yellow, reactivity, again, 0 is stable, and 4, it may detonate just looking at it. Got to have the name of the chemical up there, and again, you can use this here, and then we use a little rating system. That way it'll tell our employees how dangerous this product is, so they can immediately look at it and go, okay, that is pretty dangerous. The next one is the HMIS label. Very similar. It is a solid bar, as you can see there. Again, you have the blue at top for health. You got the red for flammability, and you got the yellow for reactivity. The only difference here is on the bottom, the white, down here at the bottom again where it says personal protective equipment, that is supposed to be white on the label, and that's for personal protective equipment. And they have an alphabetical code that goes in that block, A to K. A means you'd have to have safety glasses with side shields, and K means you'd have to have a moon suit, Tyvek suit, air supplied respirator, gloves, booties, the whole thing. And so if you use the HMIS label, you can do it. The hazard rating is the same. The only thing is you'd have to determine what the alphabetical code is, and many times when you buy these labels, they will have that listed on there for you. So you have to go back to the safety data sheet to find that out. Now, workplace labeling containers. If chemicals are placed in another container, the new container must be labeled. This is the #1 OSHA cited violation of all times. OSHA will walk in and they will pick up a product, and if there's no label on it, they will classify it as some kind of stuff. You don't know if you can drink it, eat it, get it on your skin, or breathe it. So it has to be labeled. Many times I see in the maintenance shops, I'll see basically some oils, hydraulic fluids, 3-in-1 oil, stuff like that there that get into small containers, maybe those little metal squeeze containers that they have, many times in soda containers, no label on them. They need to be labeled. Workplace labels, alternative labels, secondary labels are allowed. That's what I just talked about. We don't have to use the GHS label internally. The minimum on a label has to be the name of the chemical and the hazard warning. But whatever label that we use, we have to have adequate information immediately available to the employee so that they can go back to and determine how hazardous that chemical is. That means we have to have the updated safety data sheet immediately available, which will have this information on it. Portable container exemption. If we're only using this container to transfer chemicals from one area to the other, nobody else is using that during the day, and there's no residue of chemicals left in the container at the end of the day, you don't have to have it labeled. Again, portable container. So if I got a little container that is taken out from a labeled container and I take it and I'm pouring it into something during the day, but that container is empty at the end of the day and nobody else is exposed to it, that's what that means. But everything else has to have a label. And again, we either have to have the GHS label or an approved alternative label. Now, chemical labels, GHS format, they are significantly changed and they are significantly better than what we had before. They start out with basically pictograms. There are 9 of these pictograms on there. You have a single word. Single word will either be danger or warning. Warning means this product will make you sick. Danger means this product will kill you. So you'll start out with pictograms, 1 of 9. There might be multiple pictograms on there. You have a single word, danger or warning. You'll have a hazard statement. The hazard statement is just a very brief statement telling you how dangerous this product is. For example, it might be highly flammable liquid and vapor and may cause liver and kidney damage. Then you'll have a precautionary statement, and the precautionary statement breaks down a lot of detail about what we can do to protect ourselves. And it deals with prevention, which is 1, response, which is 2, handling and storage, which is 3, and disposal, which is 4. Those 4 things have to be covered by the precautionary statement. And all 4 of these are new to the labels. All 4 of these are much more detailed and provide a significant amount of additional information that will help us when we are looking at hazardous chemicals. Now, one of the things OSHA did when they were changing this program over to the GHS, for some reason they decided to change on the GHS safety data sheets the rating system on hazardous chemicals. And if you see up on the slide up here, they have changed this a little, reversed it. This is the HIMS and NFPA labeling requirements. And again, if you see here, 1 is slight, 2 is moderate, 3 is high, and 4 is extreme. And that still will be on HMIS and NFPA label. That's still required if you use those labels. But on the GHS, 1 now is highest, 2 high, 3 medium, 4 low. So they reversed that. But OSHA will not put these are not required to be put on the labels, but they may show up in section 2 of the safety data sheet. But if you're going to use this label here, you still have to use this rating here. And that is the common rating there. So there's some confusion with that. Not quite sure why that happened. We've asked OSHA that a number of times, and we've never got a good answer as to why we have that conflict there. But they've come out and decided that they're not going to put the new hazard rating on any of their GHS labels. These are the pictograms. You can see there's 9 of them there. The one at the top left up there is a flame. That means this product will burn. It's either combustible or flammable. It doesn't tell you the degree of hazard. It just tells you it will burn. Next, you have a flame over a circle. That means this is an oxidizer. This means this will accelerate the process of combustion. It doesn't burn in and of itself, but it will require a product to burn at a much hotter flame temperature. Next, you have the skull and crossbones. That means this product is toxic, will kill you within 4 hours. Down in the middle to the left, you have the test tube pouring acid on somebody's hand and steel. This tells you this product is corrosive, so as you see that, right off the bat, you'll know that this is a highly corrosive product. The middle one, that is a bomb blowing up. Then you have an exclamation point. That exclamation point means this product will make you sick. It will not kill you, but it will make you sick, and usually that means you have short-term impact with this particular product. You deal with this, it will make you sick fairly quickly, but it will not kill you. Down at the bottom left is a dead fish and tree. This means this is an environmental toxic. This is an ecotoxic. It will kill the fish, the worms, the trees. In the middle at the bottom is one you need to be very concerned about. This is the outline of an individual's head and chest, and you have a little heart-shaped white spot in the middle there. This tells you this product is long-term organ toxic. This is your asbestosis, this is your silicosis, this is your lead poisoning, that you're not going to die immediately, but what this means is over a long period of time, you can have serious health-related problems, and they may be permanent in nature, and they may be fatal. So very important to look at that. Last but not least is your compressed gas cylinder. So all compressed gas cylinders in the future will have to be labeled with a compressed gas cylinder sample. Here you go. There we go. This is our health hazard. You can see this little star in the chest. I asked somebody if that was a star, and they said, no, that is particles of dust being absorbed into the body. Those are toxins being absorbed through the lung into the body. And again, this is long-term organ toxic, carcinogen, mutagen, reproductive toxin, respiratory sensitizer, target organ toxic, and aspiration toxicity. All those things fall. So if you see that one there, pay attention to it on the label. If you need to ask questions, read the safety data sheet, find out a little bit more about that product. Here's a flame. Anything that will burn for any reason will have a flame. And again, that means it's either combustible or flammable. Flammable liquids, pyrophoric, self-heating, again, emits flammable gas, self-reactives, and again, there's your organic peroxides, which are extremely volatile and hazardous. We don't have any organic peroxides that we're dealing with, and many of those products here we don't deal with at all. We may have some solvents, we may have some propane, we may have some gasoline. Those are the kind of products that probably would fall into this category. Exclamation point, as I mentioned earlier, this is a short-term product that will make you sick, will not kill you. Irritant, irritates the eyes, skin sensitizer. It says acute toxicity, but under the standard it says acute toxicity, harmful, not fatal. So this product will not kill you. Narcotic effects, respiratory tract irritant, and hazards to the ozone. All these things are under this category. There's your compressed gas cylinder, pretty simple. Here's your acids or your strong bases breaking and falling on somebody's hand or in some steel. Here's a bomb blowing up, so anything that is explosive, you'll see this on here. Many of the solvents that we use, propane, those could be explosive. And here is your flame over the circle, that is your oxidizer. Again, oxygen cylinders are oxidizers. And then here's your dead fish and dead tree. That is an environmental hazard that will be regulated by the EPA. But again, if we have products in our plant or in our warehouses that can spill and get into the groundwater, that's going to be a serious violation from the EPA. So we've got to make sure if we have anything that is potentially hazardous to the environment, we're going to have spill containment or spill control in place. And there he is, my buddy Sam. Yes, he is. Look at that smile on his face. Sickening. This means this is toxic and it will kill you. So if you see that on there, make sure you pay attention to it. Now, this is a sample label that OSHA came out with. It doesn't necessarily have to be this label here, but what OSHA says is however this label comes out, 4 things have to be together. The pictograms, the single word, the hazard statement, and the precautionary statement all have to be together on the label, but the other information can be moved around a little bit. 7 different things on the label now. 6 of them are mandatory. 1 of them, the supplemental information you see down here in the right bottom corner here, that is optional. That's something the manufacturer does not have to put on the label, but it's anything else he feels like he should put on the label that will help you understand the hazards of that chemical. So if you take a look at the top, this one here has 2 pictograms. It has the health hazard, meaning this product has long-term organ toxic effects, and it has a flame. This means this product will burn. So right off the bat, you look at this here, and you can see very quickly that this product, 1, if you breathe it over a long period of time, it can have disastrous results from a health hazard, and also it will burn. It doesn't tell you it's flammable, but it will burn. Next, single word, now we know that this product, again, if you breathe it over a long period of time, it will cause fatality. It's something that will cause permanent injury and could be fatal. So there it is, the single word is danger. Then we have our hazard statement, highly flammable liquid and vapor, and may cause liver and kidney damage. There you go. This product here is probably a solvent. It might be gasoline. It might be methyl ethyl ketone. It could be xylene, anything like that whatsoever. It could be toluene, any kind of flammable chemical out there that could burn, and again gives off vapors that over the long period of time, if you breathe those vapors enough, could make you sick. Next, you have the precautionary statement. Again, I mentioned this here statement has to cover 4 areas. The first one is prevention, response, handling and storage, and disposal. So those 4 things have to be on the precautionary statement. As you can see, this is a fairly detailed statement, but again, this gives you a lot of valuable information on what you can do to protect yourself from this particular chemical. This one here starts out with simple. It says keep container tightly closed, store in a cool, well-ventilated place that is locked. Now, most of the time, chemical storage does not have to be locked, but if you have a lot of it, it should be put in a fire cabinet or a safety place, stored away from sources of ignition, stored away out of the heat. Keep the lid on at all times, and if you have large volumes of this, you should keep them in a well-ventilated room, away from other flammable areas. Keep away from hazards. Keep away from heat, sparks, open flames, no smoking. Use only non-sparking tools. Use explosion-proof electrical equipment. Take precautionary measures against static discharge. This means you need to bond it and ground it. If it's a 55-gallon drum, that means you have to have bonding straps. And that bonding strap has to go to a metal ground rod or a metal part of the structure of the building that is grounded. Also, if you're pouring out from a horizontal pour out with a spring-loaded lid, you know that you have to bond it, and bonding carries that static protection right to the container itself, so you need to make sure you're using that. If you're using one of the little crank pumps and you're setting the metal container on top of it, it will be bonded at that point because it's connected to the tank. Ground. Do not breathe the vapors. Here again, this stuff here gives off vapors. Do not breathe the vapors. Wear protective gloves as necessary. Do not eat, smoke, or when using this product, wash hands thoroughly after handling and dispose of in accordance with local, regional, national, and international regulations. So that is the precautionary statement. As you can see there, it's quite a long statement, but it gives you all kind of good information on what we can do to work with this chemical safely. Up at the top to the left, you have the name of the product up there. This will be the chemical name, trade name, product name, code name, whatever that is, that will be up there on top. Then you have the name of the manufacturer, importer, distributor, address, emergency telephone number right on there. So you'll have the name of the manufacturer, have the product name, and all that has to be on the label. And then down here again in the lower right is that supplemental information. And again, that is optional. But this is a sample what the new labels will look like. So when you see these in here, there's going to be a lot more information available to us now on the label. Now, also in this process with the new GHS, OSHA has decided to update the material safety data sheet, and I think that's a good idea. For a long period of time, many of us in the safety profession have been concerned about the safety data sheets because there was no universal form for these safety data sheets. Many of them had multiple sections that other ones didn't have. For example, many companies may have a one-page MSDS for a particular product. Another manufacturer making that same product had a 5-page MSDS. They were not in the set order. Information wasn't the same. You can have multiple different sections altogether unrelated to the same product from another company. So what we have now is we have a universal format, much more detailed, 16 sections as opposed to the 9 to 10 sections that was on most material safety data sheets. So we're going to, again, have a lot more information. Many of the sections from the material safety data sheets has been moved over to the new format, so you'll still see many of the new sections, but there are a number of other sections now have been added. And a safety data sheet is required for each known hazardous chemical that we use in our facilities, and it has to be updated every 5 years. Now, it doesn't mean we update it, but we need to make sure that we notify the manufacturers, see if they have updated it, so that we have to have the latest version. They have to be date stamped in when we get them. And if we take a chemical out of service, they have to be date stamped out of service and kept for 30 years and put into an out of service SDS or MSDS file. They need to be readily accessible in the workplace. They cannot be kept in a supervisor's office. They have to be out there where everybody can get to them. And we have to provide copies to employees based on a request. So if somebody wants to get a copy of that, we have to make a copy of that for them upon their request. And again, we now have 16 different sections as opposed to 9 to 10. And again, we have to have someone responsible for each of our facilities to oversee this program, and that individual has to have a title of Hazard Communication Coordinator for that facility. So we need to have somebody responsible to keep this program up at every site. I said before, there are now 16 sections of the safety data sheet. Each section has a specific sequence and minimum information requirements. The nice thing is that the safety data sheet is a roadmap for us to follow in order to work with a chemical safely. It tells us all the things that we need to do to protect ourselves. Each of those 16 sections is underlined, highlighted in bold. So as you go down there, it tells you a different thing to be aware of, or a different hazard, or a different sequence of what we can do to work with the chemical safely. We'll not enforce sections 12 and 15. This is interesting. There's 4 sections on there on the safety data sheet that does not fall under OSHA's jurisdiction. They fall under EPA, DOT, or other government regulatory agencies. So 12 to 15 are going to be on there, but again, they're not going to be enforced by OSHA, but they are required to be on there. And again, this whole new thing is based on the ANSI C400 standard, so they went and used the ANSI standard as the guide. So it's going to be updated. You're going to start seeing these coming in, a lot more good information. Now, what do these sections include? Number 1, right at the top, you're going to have the product identification. This will be the name of the chemical. Again, trade name, brand name, code name, product name, chemical name. So this product is bleach. You'll see at the top bleach, and then you'll see the manufacturer's name right under it. So if this is Procter & Gamble, or if this is Clorox Corporation, you'll see their name, address, telephone number, and emergency telephone number will be all right there. So when you go looking for a product in the book, you're going to see the chemical name right at the top, manufacturer, telephone number, CAS, chemical abstract service number will be on there. That is a universal number that all chemists and manufacturers use to follow a particular chemical. Section 2 is going to be hazard identification. This used to be called health hazards. It used to be Section 5 of the safety data sheets. Now they have moved that up. Everything that's required on that label that I just talked about will be in this section right here. So you'll have the pictograms, the single word, hazard statement, precautionary statement, all that will be on there, and the new GHS code, hazard code we talked about before, will be in this section. Also, anything else you need to know about the hazards of this chemical will be listed in Section 2. For example, is this a combustible dust? All that will be in this section here. Section 3 is composition. Any product in here that is hazardous has to be listed here. So if you got 14 products in a mixture and all of them are hazardous, they have to be listed here so we know what's in there. It's very, very important because some chemicals have a generic name, but the product inside can be extremely hazardous. For example, you can have a product name, and then you can have xylene making up the major part of the product. Xylene is highly dangerous. You need to know that, so that has to be listed on the safety data sheet. Any first aid measures that are required, so if we have to, get somebody the fresh air, pump their stomach, wipe their skin, wash their skin off, whatever that is, first aid measures will now be there. Firefighting measures, what do you do if you have a fire? If it's a chemical fire, I'm going to simply request that we all follow Plan B, which is get out of the building, okay? Call 911, make sure everybody goes to the collection area. But small fires, if it's a small incipient stage fire and you feel comfortable about it, you can use an ABC type fire extinguisher. They will work, they will put out a small basic fire. But anything more serious than that, we want everybody out of the building immediately. Accidental release, what happens if we spill this product all over the place? Can we clean it up here with normal cleanup material? Or do we have to have a hazmat team come in here? We do not have anything right now that we're using in any of our facilities that's going to require a hazmat team. That means we can clean up everything that we have with normal cleanup material. Absorbent materials, absorbent pads, that. Make sure anybody gets involved in it has appropriate personal protective equipment. Keep it away from the drains. Don't let it get outside. If we have 55-gallon drums that we're using in the plant, it's a good idea to store those on EPA spill prevention pallets so that if there is a leak in the drum, it will go down in the pallet. It will not get out on the floor, and it will not get into the drain system and get into the water system outside. Handling and storage, the more dangerous this product is, the larger this section will be. Gasoline, for example, will have a fairly large section on how to handle and store it. For example, if you read a gas pump at the local gas station, it's going to tell you a couple things. One, do not get in and out of your car. Do not leave the area if you have it in automatic. Do not smoke. Do not leave the engine running. Do not create any static sparks. Do not put this in unapproved containers. Do not use a plastic container and put it on top of a bed liner of your pickup truck because there's no bond there. So all these types of things that will tell you, same thing here. Exposure control and PPE. Yeah, what do you do for control? For example, if we have wood dust in the area, we have to vacuum and have to have adequate ventilation in there. If we're dealing with exposures to certain types of chemicals, this will tell you what the engineering controls are, what the administrative controls are, and it will also tell you what kind of personal protective equipment. So personal protective equipment is required for the use of this chemical. It's going to be listed right on the safety data sheet, and it'll be specific as to the type of PPE, right down to the types of gloves. You got to be very careful with that. You got to go to the safety data sheet if you're dealing with a particular chemical to make sure the kind of gloves we have are compatible with that chemical. Physical and chemical properties, this is the color, the odor, the state. Does it evaporate rapidly? Does it dissolve in water? Is it heavier or lighter than water? All that information is on there if you're interested in that. Stability and reactivity, does this react violently with other chemicals? Very, very important to know. Or is it one of these chemicals that will react all by itself, just sitting there? Next, toxicological information. What are the studies on this chemical by our research institutes that have studied this chemical, and what are the results of that? If there is any of those major studies, many of that will be right here, toxicological information, so that you can go and read that there and you can see what this product does to your body organs over a long period of time. 12, 13, 14, and 15, if you take a look at those, they all have those little red stars next to them. That means these are not regulated by OSHA, but are required on the safety data sheet. And the first one's going to be ecological information. Does this kill the fish, the birds, the worm? If you get this out of the plant into the groundwater, what is the damage this product will do? This will be listed here. And again, that is an EPA covered requirement. Disposal considerations. How do you dispose of this? Do you need a hazmat team to dispose of it? Do you need Safety Clean to come in? Or do you need Clean Harbor to come in here? What do you need to do to dispose of this product safely? Can I put it in the regular dumpster? How do I handle that? Very important before, if you have a spill or cleanup, you need to know how you get rid of this product safely. DOT, here we go, number 14. Any placarding is required on any of these products here. Right now, Palmer Donovan doesn't have, we handle no products that exceed any of the requirements of DOT requiring placarding. But if you are required to have placarding on any of your chemicals, make sure you see your warehouse manager to see what kind of placarding. We do have the placarding available, but again, right now we're not handling any hazardous chemicals, shipping any hazardous chemical that requires any DOT placarding. And next is regulatory information. This is any other federal agency that oversees the safety of this particular product. Railroad Administration, Federal Aviation Administration, can you take this product on the plane? Yes or no? Or what are the safety requirements before you do that? Same thing with the railroad and maritime industries. So these are all different agencies in the federal government that regulate, that certain activities, and again, they regulate certain chemicals under their jurisdiction. Last but not least is any other information that the manufacturer wants to put on the safety data sheet. Again, it could be anything at all that they think may help you better understand the hazards of the chemical or work with the chemical safely. So these are the new 16 sections. They're quite detailed. Nice thing is there's going to be a universal order from now on. They're all going to be in the same order, same basic information. The other thing is they're all going to be highlighted, underlined, and bold. So you don't have to read every section of the safety data sheet. Matter of fact, I recommend that when you go to the safety data sheet, what is the question that you have? Go to that particular section first. So if you want to know what the health hazards are, go to section 2. If you want to know how to fight the fire, go to section 5. If you want to know what the physical properties are, go to section 9. If you want to know toxicological information, go to section 11. If you want to know exposure control, what you do to protect yourself and the types of PPE, go to section 8. That's how I read a safety data sheet, and then I backtrack from there to the other sections. But again, these need to be immediately available out in the plant where employees can get to them. And if employees have a question, we need to have somebody available to assist them in reading the safety data sheet. Now again, training. Employees shall provide employees with effective information and training on hazardous chemicals. 1, at the time of initial assignment. So when people start, they have to be trained. In our manuals is a safety training sign-off sheet for hazard communication. That should be used, so when we cover this, we document the training that our new employees get. Whenever a new hazard is introduced, when transferring, if an employee is transferring from one unit to the other and he has different exposures to chemicals, we got to make sure he is trained in that. When returning from extended leave, also on a regular basis as established by the company. OSHA doesn't say this training has to be done annually, but they want it done on a regular follow-up basis. And what do we got to cover? 1, how to read a material safety data sheet, explain that in detail for everybody, explain our labeling system, explain the GHS label system in there, so we cover that with all of our employees. General training, hazard communication, standard things I'm covering right here. Employer's written program, where is it at? How does employees get access to it? Location and availability of the written program and safety data sheets. How to read the labels and safety data sheets. Characteristics of the chemicals that we deal with and how to detect an exposure. Most of the time, if you have a release of a chemical, you can see it fairly quickly. Also, you can usually smell it well in advance. So if you see something down there, if it's coming from a 55-gallon drum, it's probably not going to be Hershey syrup, okay? It's probably going to be some kind of oil, some kind of solvent, some kind of lubricant. Work practices or safe procedures. How do you work with this chemical safely? And again, what kind of personal protective equipment? If we do have a spill, what are our emergency procedures? And again, we do not have anything right now that if we spill it is going to require a hazmat team or an evacuation of the facility. Everything we have can be cleaned up pretty easily with most of our employees using normal cleanup material that should be available in our plants. Non-routine tasks, we're really not going to get into any of these. This is more of a maintenance-related function where they're working on something that they don't get exposed to on a regular basis. If we have those tasks, we have to let our employees know in advance what are the hazards of the chemicals that they are exposed to. And then if we do any industrial hygiene monitoring where we want to determine if we have an exposure of a particular chemical at or above a known PEL, that is a permissible exposure level for industrial hygiene, and we will do that as necessary, and those results are available upon request. Written program, we have it here, outlines all the different things we're going to do. Also, if we have outside contractors coming into the building, and the outside contractors are bringing hazardous chemicals in that our employees may be exposed to, we have to know what those are. We have to have a copy of their MSDSs or safety data sheets. We have to have education if necessary, and same thing with them. If we have certain types of hazardous chemicals that our contractors could be exposed to that could cause them physical harm or illnesses, we have to let them know that also. So this is a big standard. Palmer-Donner is going to do everything that we can to comply with this standard, but we want to make sure we get the training updated, we get the safety data sheets available immediately, we have our master chemical inventory list updated on a regular basis, and we have all the other elements of our program, and we're documenting everything carefully. So if OSHA comes in and asks us, we can show them the documentation. So that is the program there. We need to make sure that gets covered in detail.